Now, in this video, we will going to discuss about the concept of generalized Hooke's law. So what the Hooke's law says? The generalized Hooke's law states that when a body is subjected to normal stresses, what is the normal stress? The normal stress is the one which is acting perpendicular to the lateral dimension or the lateral surface. The normal stress is on three mutually perpendicular directions, which is sigma x, sigma y, and sigma z, are the stresses which is applied on the member which is on x, y, z. So what is the net strain along x direction? Net strain along x axis will be equal to the longitudinal strain due to sigma x acting along x direction, then the lateral strain along x axis due to sigma y acting in y direction, and the lateral strain along x axis due to sigma z acting along z axis. So that means longitudinal strain, that is sigma x acting along x axis, lateral along x axis, that is with reference to the x axis, due to sigma y is acting in y along y axis, and then the lateral strain, that is sigma z on this along x axis with reference to the x axis due to sigma z in z direction. So when you are considering the x axis, longitudinal direction is along the x direction only, along x axis. Now considering sigma y with reference to x, it becomes lateral. Sigma z with considering with the x axis, it becomes lateral. That is the meaning of this. So therefore, two important relations used in finding the net strain along x directions or x axis are, one is the Hooke's law and the other one is the Poisson's ratio. According to Hooke's law, what does it mean? What is Young's modulus? E will be equal to linear or longitudinal stress by linear or longitudinal strain, which is sigma by epsilon. So therefore, the longitudinal strain epsilon will be equal to sigma by E. So therefore, ratio of lateral strain to the longitudinal strain is now comes with the Poisson's ratio. So one is the Hooke's law. Hooke's law is sigma by E is epsilon. So when you are considering the Poisson's ratio, it is the lateral strain to the longitudinal strain is known as Poisson's ratio. It is a constant within the elastic limit. So what is 1 by m? 1 by m is the lateral strain by the longitudinal strain, which is epsilon lateral into epsilon lateral by epsilon longitudinal. So what is epsilon lateral? Epsilon lateral will be equal to 1 by m into epsilon longitudinal. So what is the longitudinal strain along x-axis due to sigma x will be equal to sigma x by E. So that is positive because it is the tensile stress. Now the lateral strain along x-axis due to sigma y will be equal to minus 1 by m into longitudinal strain along y direction due to sigma y. So that is minus 1 by m into sigma y by E. So that is equal to minus sigma y by m into E, because sigma y is tensile stress. So there is a negative sign that is here, that is because it is the tensile stress. Similarly, lateral strain along x-axis due to sigma z, minus 1 m by m into longitudinal strain along x direction due to sigma z, that is equal to minus 1 by m into sigma z by E, that is equal to minus sigma z by m into E. Again, minus sign, sigma z is the tensile stress. With reference to the x-axis, it will go into the change in the lateral dimension, it is decreasing. Therefore, it will going to be the negative sign. What is the net strain? Net strain will be equal to epsilon x will be equal to sigma x by E minus sigma y by m into E minus sigma z by m into E. So similarly, net strain along y direction, y axis, which is epsilon y, will be equal to, along the y direction it will be sigma y by E minus sigma z by m into E minus sigma x by m into E. Similarly, net strain along z axis epsilon z will be equal to, along the direction of the z axis will be sigma z by E, and correspondingly with reference to the sigma x and sigma y will be negative. minus sigma x by m into E minus sigma y by m into E. So what is the total volumetric strain on the three mutually perpendicular stresses? So here again, volumetric strain due to three mutually perpendicular stresses, which is considered a rectangular block subjected to three tensile stresses, which is sigma x, sigma y and sigma z in three mutually perpendicular directions, which is as shown in the figure. So again, L into B into D, where here length in the x direction, B is in the y direction, D is in the y direction and B is in the z direction. Therefore, volume of the block B will be equal to L into B into D. So taking the log on both sides, log B will be equal to log L plus log B plus log D. Differentiating, so 1 by V into delta V, that is delta V by V, that is equal to 1 by N into delta L, that is delta L by L plus delta V by V plus delta D by D. So where delta V is the change in volume, delta L is the change in length, delta B is the change in width and delta D is the change in thickness. So what is delta V by V, which is nothing but epsilon V. So delta L by L will be equal to epsilon X plus delta B by B is epsilon Y plus delta D by epsilon Z. So therefore it will be epsilon V equals epsilon X plus epsilon Y plus epsilon Z. So where epsilon V will be equal to the volumetric strain. So then tensile stress in the direction of XX will be sigma X, tensile stress in the direction of YY is sigma Y, and tensile stress in the direction of ZZ will be equal to sigma Z. So now what we will going to get, sigma X will be producing the tensile strain, that is sigma X by E in the direction of XX, compressive strain in the direction of XX, that is sigma X by M into E in the direction of YY and ZZ when we are considering sigma X. Similarly, sigma Y will produce tensile strain along Y direction, that is sigma Y by E in the direction of YY. Compressive strain is equal to sigma Y by M into E in the direction of XX and ZZ. So sigma Z will produce tensile strain sigma Z by E in the direction of ZZ. Compressive strain, which is sigma Z by M into E in the direction of XX and YY. So therefore, hence by the generalized Hooke's law, what is the total strain? That is the longitudinal strain induced in the direction considered load plus sum of the strains that is in the lateral in the remaining two directions. So what is the total strain along the direction of XX? Epsilon X will be equal to sigma X by E minus sigma Y by M into E minus sigma Z by M into E. Similarly, total strain along in the direction of YY, which is epsilon Y, will be equal to sigma Y by E minus sigma Z by M into E minus sigma X by M into E. Similarly, total strain in the direction of ZZ will be equal to epsilon Z, which is sigma Z by E minus sigma X by M into E minus sigma Y by M into E. So what is epsilon V? So total strain of all these things, sigma X by E minus sigma Y by M into E minus sigma Z by M into E plus sigma Y by E minus sigma X by M into E minus sigma Z by M into E. Similarly, substituting the values, that's all what I am doing here, which is sigma Z by E minus sigma X by M into E minus sigma Y by M into E. So take out, rearranging the equation, sigma X by E plus sigma Y by E plus sigma Z by E minus 2 sigma X by M into E, because here sigma X by M into E minus sigma X by M into E, that is minus 2 sigma X by M into E, and here sigma minus sigma Y by M into E minus sigma Y by M into E minus 2 sigma Y by M into E, here minus sigma Z by M into E minus sigma Z by M into E. So you will go to get it as minus 2 sigma Z by M into E. Now take out the common factors, sigma X by E plus sigma Y by E plus sigma Z by E minus 2 by M into E into sigma X plus sigma Y plus sigma Z. Now you take 1 by E as the common factor, sigma X plus sigma Y plus sigma Z by total E into 1 minus 2 by M. Therefore, the volumetric strain of the rectangular block will be equal to sigma X plus sigma Y plus sigma Z by E into 1 minus 2 by M. If sum of these stresses is equal to 0, that is sigma x plus sigma y plus sigma z is equal to 0, then the epsilon v will be 0. Hence, there is no change in volume. So this is how you will be able to derive the expression for the volumetric strain for the rectangular block. If you find this video is useful, please subscribe to my channel. Thank you.